Dear students, in this lecture video we are going to solve a problem which is described by a governing differential equation using Galerkin's weighted residual approach. The differential equation of a physical phenomenon is given by d square y by dx square plus 500x square is equal to 5 between the limits 0 to 1. Use the trial function y is equal to a1 into x minus x power 4. The boundary conditions are given as y of 0 is equal to 0 and y of 1 is equal to 0. We are asked to calculate the value of the parameter a1 in the trial function by the Galerkin's approach. So the given differential equation is d square y by dx square plus 500x square is equal to 5. We can take this as equation 1. This equation is valid for x is equal to 0 to 1. The boundary conditions of the problem are given as y at x is equal to 0 is equal to 0 and y at x is equal to 1 is equal to 0. Okay. The trial function for the given problem is given as y is equal to a1 into x minus x power 4. We can take this as equation 2. So now before starting the problem we have to check that the given trial function satisfies the given boundary conditions or not. Okay. So first apply the first boundary condition in equation 1. The trial function is y is equal to a1 into x minus x power 4. The first boundary condition is y at x is equal to 0 is 0. That is, when x is equal to 0, the function y is equal to 0. Okay. By applying the first boundary condition in the trial function, y of 0 is equal to a1 into 0 minus 0 power 4. Okay. So 0 minus 0 is 0. So y of 0 is 0. So when we substitute the value of x is equal to 0 in the trial function, we will be arriving at y is equal to 0. So the first condition is satisfied by the trial function. Then considering the second boundary condition, y of 1 is equal to 0. That is, when x is equal to 1, y is equal to 0. Okay. Applying the second boundary condition in the trial function by substituting the value of x is equal to 1 in the trial function, a1 into 1 minus 1 power 4. So 1 minus 1 is 0, so this becomes 0. So when we are substituting the x value as 1 in the trial function, then the output y becomes 0. So the second boundary condition is also satisfied by the trial function. So the trial function satisfies both of the given boundary conditions. So we can proceed the problem with the given trial function. So to solve the problem using Galerkin's weighted residual approach, we have to frame the residual function. Okay. The given differential equation is d square y by dx square plus 500x square is equal to 5. We have a valid trial function in the problem, that is y is equal to a1 into x minus x power 4. To compare these two equations, we have to raise this trial function to order 2. Okay. So for that we have to differentiate once this trial function with respect to x. So dy by dx is equal to a1 into the differential form for x is 1 minus the differential form for x power 4 is 4x cube. To compare this with the given differential equation, we have to once again differentiate with respect to x. So d square y by dx square is equal to a1 into the differential form for 1 is 0. The differential form for any constant value is 0. So here the differential form for 1 is 0 minus 4 into the differential form for x cube is 3x square. So d square y by dx square is a1 into minus 12x square, that is minus 12a1x square. Okay. So now we can compare this d square y by dx square with the d square y by dx square present in the given differential equation. So on comparing these two d square y by dx square, we can replace this d square y by dx square by this d square y by dx square. So minus 12a1x square plus 500x square then the term 5 present in the right hand side of the governing differential equation can be brought to the left hand side as minus 5. This is our residual function. Galerkin's weighted residual approach suggests a formula that integral 0 to L Wi r dx is equal to 0. Okay, so here 0 to L is the limit of the function, Wi is the weight function, r is the residual function. So in the problem, the given range is 0 to 1. Weight function is nothing but it is the coefficient term of the constant value present in the trial function. So the trial function is y is equal to a1 into x minus x power 4. Here the coefficient term for the constant value present in the trial function is the weight function, that is x minus x power 4 into the found out residual function is minus 12 a1 x square plus 500 x square minus 5 into dx is equal to 0. Okay, so on multiplying both the terms, that is x minus x power 4 with the residual function, we will be arriving at minus 12 a1 x cube plus 500 x cube minus 5x plus 12 a1 x power 6 minus 500 x power 6 plus 5 x power 4 into dx is equal to 0. Okay. In the next step, we can integrate the expression with respect to x. The integral form for the first term, that is minus 12 a1 into x power 4 by 4. For the second term, 500 x power 4 by 4 minus for the third term 5 x square by 2 plus for the fourth term 12 a1 x power 7 by 7. For the fifth term 500 x power 7 by 7. For the sixth term 5 x power 5 by 5. The limits are 0 to 1. This is equal to 0. In the next step, we can substitute the upper and lower limits. Here, this 4 and 12 can be simplified like this, and this 5 and 5 can be cancelled. On substituting the upper limit, 1 minus 3 a1 into 1 power 4 plus 500 by 4 into 1 power 4 minus 5 by 2 into 1 square plus 12 by 7 a1 into 1 power 7 minus 500 by 7 into 1 power 7 plus 1 power 5. While substituting the lower limit, that is 0, all the terms will be 0 is equal to 0. On grouping the a1 terms, minus 3 a1 plus 12 by 7 a1, we can bring all the constant values in the right hand side of the expression. So this is minus 500 by 4, this is plus 5 by 2, this is plus 500 by 7, this is minus 1. On the left hand side, the simplified term will be minus 1.2857 a1 is equal to the simplified term in the right hand side as minus 52.0714. So the a1 value can be obtained as 40.5. On substituting the value of a1 in the considered trial function, y is equal to 40.5 into x minus x power 4.